exploring different ways to solve quadratic equations, and in this unit we're going to be completing the square. So completing the square involves using perfect square trinomials. So just as a quick review, when we had a perfect square, so a binomial times itself, that's a plus b times a plus b, and we FOIL it out, we get a squared plus 2ab plus b squared. And if we had a minus b squared, that was a minus b times a minus b, which gave us a squared minus 2ab plus b squared. So for example, x plus 3 squared, x would be a, 3 would be b, so I'm going to square the x. I'm going to go 2 times x times 3, which will give me 6x, and then 3 squared will give me 9. And just as we could FOIL out a perfect square, we could factor a perfect square, and a squared plus 2ab plus b squared would give us a plus b squared, and a squared minus 2ab plus b squared gave us a minus b squared. So for example, if I had x squared plus 10x plus 25, the square root of x squared is x, the square root of 25 is 5, 2 times x times 5 was 10, so I got x plus 5 squared. I'm going to use this in order to solve our quadratic equations. Now, not every quadratic equation will use or have a perfect square trinomial, so what we're going to do is we're going to force the equation to be a perfect square trinomial so that it's easy to factor. And that's the process of completing the square, and in order to do that, we need to determine what number goes here. So the first step on doing that is we identify b. Okay, now this is a different b than the a plus b. If you recall, quadratic equations are of the form x squared plus bx plus c, or sometimes we say the ax squared plus bx plus c, but because we don't want a coefficient on the a, we're just using the form x squared plus bx plus c for now. So we identify b. b is 10. And once we've identified b, we're going to take b and we're going to divide by 2. So I'm going to take that 10 and I'm going to divide it by 2, and that'll give me 5. The next step is to then square the answer from step 2. So 5 squared is 25. This is C. So in order to have a perfect square trinomial, we have x squared plus 10x plus 25. And if we wanted to factor that, x plus 5 squared, and this becomes easy because the number that we got here tells us what to put right here. And the sign that we have here tells us which sign to have right there. So let's try a couple. In this instance, b is 4. So I'm going to take that 4 and I'm going to divide it by 2, and that's going to give me a 2. My next step is I'm going to take that 2 and I'm going to square it, and that's going to give me a 4. This is C. So my perfect square trinomial is x squared plus 4x plus 4, and if I factor that, that's going to equal x plus 2 squared. And again, this 2 tells me that this needs to be a 2. In this instance, my b is 8, so I'm going to take that 8 and I'm going to divide it by 2, and I'm going to get 4. And I'm going to take that 4 and I'm going to square it, and I'm going to get 16. This number is c. So my perfect square trinomial is r squared minus 8r plus 16. Now, you'll notice this was still plus. That's because perfect squares are always plus. So this c will always be positive. If I were to factor this one, I'm going to get x minus 4 squared. Again, because this number tells me which number to come here, and this sign tells me which sign to go there. Now sometimes c is not going to be even. So when that happens, we can just write it as a fraction and get 5 halves. So 5 divided by 2 is 5 halves. I'm going to take that 5 halves and I'm going to square it, and that means I'm going to square the 5 and I'm going to square the 2. So this is going to be 5 squared over 2 squared, which is going to be 25 over 4. This is c. So I'm going to have x squared plus 5x plus 25 over 4. Don't let the fact that it's a fraction trip you up. I can also factor this. Follows the same pattern. Even though we have a fraction, that doesn't matter. Fractions are perfectly legitimate. We just write them there. Finally, 50. 50 divided by 2 gives me 25. 25 squared gives me 625. This is c. So my perfect square trinomial is x squared minus, y. Messed up my letters. Y squared minus 50y plus 625. And to factor this, I'm going to get x minus 25 squared. 25, 25. So now that we've figured out how to complete the square, we can use these to solve equations. What we have is a non-perfect square right here, and we have that equal to some number. If I try to take the square root of 12, it's not perfect, so therefore I know this is not a perfect square. I want to force it to be a perfect square so I can easily factor and solve this equation. The first thing I need to do is I need to make room for c. I need c to be a perfect square, and I need it in this space right here. So in order to do that, I need to get rid of this 12. So my first step is that I want x's on one side, solo numbers or constants on the other. So I'm going to add or subtract to make that happen. In this case, since it's a positive 12, I'm going to subtract 12 from both sides. That will leave me with x squared minus 6x is equal to 7. And as you can see now, I've left room for c. Once I've done that, now I need to determine c. So I'm going to divide b by 2, then square it. b is negative 6, so I'm going to take that 6, I'll divide it by 2, that'll give me 3. I'll take that 3, I square it to get 9. This is c, right here. So I've determined C. Once I have C, I want to then add C to both sides of the equation. I can't just put C, sorry about that. I can't just put C in this blank, that would no longer be true. I actually have to add it to both sides of the equation. So I'm going to get x squared minus 6x, and I have that 7, and I'm going to add C to both sides. And simplifying that will give me x squared minus 6x plus 9 is equal to 16. Once I've got my perfect square trinomial, I need to factor it. Which I can easily do, because as you recall, this number tells me what goes here, and this sign tells me what goes here. So x squared minus 6x plus 9 is equal to x minus 3 squared. So I end up with x minus 3 squared is equal to 16. Now I want to solve this, and so in order to solve, I'm going to take the square root of both sides. Okay, and the reason I take the square root of both sides is because square roots and squares cancel each other out. And I will be left with x minus 3 is equal to, actually I don't need parentheses on that. Ooh, wow, that was way too big. I don't need parentheses on that anymore. So I'm just going to clean that up a little bit, actually. And I'm going to have x minus 3 is equal to. Now, here's where you want to be really careful. The square root of 16. Well, the primary square root of 16 is 4 because 4 times 4 is 16. And that's true. But negative 4 times negative 4, which is negative 4 squared, is also 16. And we don't know for a fact if it was a positive 4 or a negative 4. So we end up with a plus or minus. This is very important. You always want to have this plus or minus on these. So plus or minus 4. Then my next step, with quadratics, you get two answers. So step 7 is to both add and subtract. Okay, so I'm going to have 3 plus 4 and 3 minus 4. And I'm going to get two answers for x. They're going to be 7 and negative 1. This is one way to write the answer. Or I can put it in set notation or solution notation. So my solutions are 7 and negative 1. Now I can check myself if I want to by going in and plugging those answers both into this original equation to see if that would work. So I'm going to do that really quickly. I have x squared minus 6x plus 12 equals 19. So my first answer was 7. Yes, 7 squared minus 6 times 7 plus 12 equals 19. 49 minus 42 plus 12 equals 19. 49 minus 42 is 7 plus 12 equals 19. 19 equals 19. So we know that 7 works. And I can try negative 1. Negative 1 squared minus 6 times negative 1 plus 12 equals 19. And I get 1 plus 6 plus 12 equals 19. 7 plus 12 equals 19. And we know we got the right answers. Let's try a couple more of these. So again, the first thing I want to do is I want to get this 3 out of the way so I have room to put c. So I subtract it from both sides, and I get x squared minus 12x equals 5. Then I want to find c, so I'm going to take that 12, divide it by 2, I get 6. I square my 6 to get 36. That's c. And that's what I want to add to both sides. So I get x squared minus 12x plus 36 is equal to 5 plus 36. Simplifying, five plus 36 is 41. Okay, now I'm going to factor. This is going to give me x minus 6 squared is equal to 41. And then I'm going to take the square root of each side. Now 41 is not a perfect square. 41 is actually a prime number. So when I take the square root of this side, I'm going to get x minus 6. When I take the square root of this side, I'm going to get plus or minus the square root of 41 because I can't simplify it. I'll add 6 to both sides, and I will get x is equal to 6 plus or minus the square root of 41. And this is actually a perfectly acceptable answer unless you're told to give your answer to the nearest tenth or hundredth, something like that. You can leave this just exactly like this. Now, if you are told to give your answer in the form of a decimal, that's actually rounding. This is exact, that wouldn't be. We can do that. You'll take your calculator and you'll plug in 41 and take the square root of it. We're going to get 6.403, which to the nearest tenth would be 6.4. So this would translate to 6 plus or minus 6.4. 6 plus 6.4, 6 minus 6.4. So x would equal 12.4, or x would equal negative 0.4. Now I'm going to make this squiggly because we are estimating, so it's approximately equal. This is when you rounded. Okay, but again, this is a perfectly acceptable answer unless you're told to give it in decimal form, in which case you take the square root on the calculator and then add and subtract it. Let's try one more. I've got this 21 I need to get rid of. So I'm going to subtract it from both sides, and I'm going to have x squared plus 3x is equal to 1. I'm going to take half of 3, and that's going to give me 3 halves, and then I'm going to square it, which is going to give me 9 over 4, because 3 squared is 9, 2 squared is 4. And I'm going to add that to both sides. Now, this side, that's pretty easy because nothing combines, so I can just write 9/4. But 1 plus 9/4 might give some people a little bit of a hard time. So, just as a quick side note, when we add fractions, we need that common denominator. So 1 is the same thing as, I want fourths, so 4 over 4. And then I can add 9/4 plus 4/4, which was the same as 1, and I'm going to get 13/4. So 13 fourths. I'm going to factor my perfect square, and I'm going to get x plus 3 halves squared is equal to 13 fourths. I'm going to take the square root, take the square root of both sides, and this will give me x plus 3 halves is equal to, now remember the square root of a fraction is the square root of the top over the square root of the bottom. Now I cannot simplify square root of 13, but I can simplify the square root of 4, which is 2. Big thing not to forget though is I've got that plus or minus out front. So I have x is plus 3 halves is equal to plus or minus 13, square root of 13 over 2. Subtract 3 halves from both sides, and you get x is equal to negative 3 halves plus or minus square root of 13 over 2. Because these match, those are like terms, so I can combine these into one and leave that negative 3 plus or minus the square root of 13 all over 2. That will be my final answer, and that is a perfectly acceptable answer, unless of course you're asked to give your answer in decimal form. Now in all of these situations we've had a coefficient of 1 on the very first term, which makes completing the square very simple. If that first term is not a 1, you have to make it a 1 in order to complete the square. So the first step in this instance is divide everything by a. Okay, so just keep in mind we have ax squared plus bx plus c. So we want to take whatever a is and divide everything by a to get rid of it. I do mean everything, every single term. So these negative 2's will cancel. 8 divided by negative 2 is negative 4. Negative 18 divided by negative 2 is positive 9. 0 divided by everything is 0. Step 2, x is on one side, number on the other. So I need to subtract 9 from both sides. And I get x squared minus 4x is equal to negative 9. Step 3, find c. So I'm going to take that negative, or that 4, divide it by 2 to get 2. I'm going to take that 2 and I'm going to square it to get 4. And I'm going to add c to both sides. So we have x squared minus 4x equals negative 9, and I'm going to add c to both sides. And I believe I might have made a typo, but that's okay because this will work out. I'm going to factor, or actually I'm going to simplify this first. Then I'm going to factor. And I'm going to get x minus 2 squared is equal to negative 5. And I'm going to take the square root of both sides. And here's where I say I did my typo. I wasn't supposed to get a negative answer here. I can't have a negative square root. If this happens, you write no real solutions. because we're in the real number system. This number right here is not real. So when that happens, if you have to take a square root of a negative, you have no real solutions and you're done. Had we done this properly, that should have been a positive 5. Would have gotten x minus 2 is plus or minus 5, and we'd have gone from there. But the important thing is, the only thing that's different is we have to get rid of this coefficient on the x squared first. So let's try a couple of those. We have 3, so I'm going to divide everything by 3. And I'm going to get x squared minus 3x minus 1 is equal to 7. I need this space open, so I'm going to add 1 to both sides. Get that cleared out. And I'm going to have x squared minus 3x is equal to 8. Then I need to find c, so I'm going to take that 3, divide it by 2 to get 3 halves. I'm going to take that 3 halves, I'm going to square it to get 9/4, and then I have to add that to both sides. So plus 9/4 plus 9/4. So 8 is equal to how many fourths? Well, 4 times 8 is 32. So 8 is equal to 32 fourths. 32 fourths plus 9/4 is equal to 41 fourths. So what I have is x squared minus 3x plus 9/4 is equal to 41 fourths. Factor my perfect square. This is negative, so this is negative. Take the square root of both sides. This will give me x minus 3 halves is equal to, now recall, take the square root of the top and the square root of the bottom. 4 is a perfect square. 41, however, is not. And don't forget your plus and minus here. So I have x minus 3 halves is equal to plus or minus the square root of 41/2. Need to add 3 halves to both sides. And so I get x is equal to 3 halves plus or minus the square root of 41/2. Since my denominators match, I need to combine this. Sorry, this is so cramped. That should be plus or minus. Let's try that again. So 3 plus or minus the square root of 41/2. This one's going to take a bit of rearranging first, so I'm going to go ahead and put this into sort of more standard form. This 10x is going to come over, so it'll be negative now. And this 5 is going to go over there, so it'll be negative now because we switched sides. And anytime you switch sides, it's like you're switching teams, so you change your jersey. If you're positive on one, you're negative on the other, and vice versa. Now I need to divide everything by 4. And I'm going to get x squared minus 10/4 is going to reduce to 5 halves is equal to negative 5/4. Now, taking half of a fraction, 5 halves divided by 2. That's the same thing as 5 halves times 1/2. So that makes it 5/4. And then I need to take that 5/4 and I need to square it, and I'm going to get 25/16. And that is what I'm going to add to both sides. And 5/4 is equal to 20/16. So I get x squared minus 5 halves plus 25/16 is equal to 20/16 plus 25/16, so 45/16. So I have x minus 5/4 squared, because don't forget this is the number that goes here, is equal to 45/16. I'm going to take the square root of both, and I get x minus 5/4 is equal to plus or minus the square root of 45 over 4. Now 45 is not a prime number. We've been dealing with all prime numbers, so we need to simplify the square root of 45. 45 is 5 times 9, and 9 is 3 times 3, and 3 and 3 are a pair, so they get to come out. So I get 3 times the square root of 5. So x minus 5/4 is actually going to be equal to plus or minus 3 times the square root of 5 over 4. These fourths will add up together. So when I add 5/4 to both sides, I can go ahead and write x is equal to 5 plus or minus 3 times the square root of 5 over 4. Now, we're always going to end up with word problems, so let's go ahead and try a couple of these. The senior class at Bay High School buys jersey to wear to the football game. The cost of the jerseys is modeled by this equation here. So here is our equation, and C is the cost, and X is the number of jerseys. So we want to know how many can they buy for $430. $430 worth of shirts. First thing I need to do is I need to get rid of this coefficient. So I'm going to divide everything by 0.1. 0.1. So I'm going to get x squared is equal to 20. Oops, not equal to, sorry. X squared plus 24x plus 250 is equal to 4,300. I don't want this 250 here, so I'm going to get rid of it. So I'm going to get x squared plus 24x is equal to 4050. And I'm going to take 24, I'm going to divide it by 2, and then I'm going to square it, and that's going to go right here where C goes. So I get x squared plus 24x plus 144 is equal to 4194. Factor, and I'm going to have x plus 12 squared is equal to 4194. Take the square root of both sides, and I get x plus 12 is equal to, oh, whoops, big mistake, plus or minus, I forget this. So let's find out what the square root of 4194 is. 64.76. Alright, so I'll do 64.76 plus or minus. So maybe write that right here. X plus 12 is equal to plus or minus 64.76. subtract 12 from both sides. And so I'm going to get x is equal to 12 plus 76, sorry, and 12 minus 76. So x is equal to, sorry, this is negative 12. Don't forget that. Either 52.76, which is approximately 53 jerseys, but because we can't go over how much money we have to go down one, so 52 jerseys, or negative 76.76. Well, we're talking about jerseys. We can't have negative jerseys. So this answer is not valid. So our answer is going to be 52 jerseys can be bought with $430. Okay. Another example uses physics. We have the height of an object t seconds after it is dropped is given by this equation, where HO is the initial height, G is the acceleration due to gravity. We have the acceleration due to gravity on Mars is 3.73 meters per second, and on Earth it is 9.8 meters per second. We're going to drop an object from an initial height of 120 meters above the surface of each planet. Okay, which planet would the object hit the ground first? Well, acceleration is the key to this. Mars is 3.7 meters per second. Earth is 9.8 meters per second. It means the gravity on Earth is faster, it's stronger. So it'll hit on Earth faster because it's going to fall faster. How long will it take the object to reach the ground on each planet? We're going to have to solve for t. Okay. That will make this height. So we'll start with h is equal to 1/8. Wow, my handwriting's not very good on this one. Sorry about that. Let me fix that. H is equal to 1/8 gt squared plus ho. Well, our initial height is going to be 120. Our gravity is going to change versus the planet. We're talking about hitting the ground. So if we hit the ground, we're at 0 meters. Okay. So I'm going to go to another sheet of paper just to make this easier, to have more room. And I'm going to set this up. So I've got 1/8 of gravity. Now gravity on Mars, let's do Mars first. 1/8 of the gravity. The gravity on Mars is 3.73 meters per second squared. So 3.73 t squared plus ho. So plus 120 is equal to 0 because we're trying to find out when it hit the ground. So I need to do 1/8 times 3.73. Anytime you have a 1 over a number, that means to divide by that number. So I'm going to do 3.73 divided by 8. So I have 0.4. How much did it say to round to? Tenths. Okay, so 4.7 or 0.47, sorry, 0.47 t squared plus 120 equals 0. I want to get rid of that 120. So I have 0.47 t squared is equal to negative 120. I don't have a b term. Let me just double check this. Yep, see, no t. Well, that means we can just get t squared by itself. I'm going to divide by 0.47. And I have t squared is equal to 120 divided by 0.47. So 255.3. And my b term would be 0, and if I take half of 0 and I square it, I get 0, and so I'd add 0 to both sides and end up exactly where I am right now. So I'll take the square root of both sides. So 15.97, that's going to round up to 16 plus or minus. But can we have negative time? It's time. Time is always positive. So on Mars, it'll take 16 seconds for that object to hit the ground. Now on Earth, let's write that down. So Mars, 16.0 seconds. Earth has a 9.8 meters per second gravity. So I'll take that 9.8 and divide it by 2 to get 4.9. I want this 120 to go away, so I'm going to subtract it from both sides. And I get 4.9 t squared is equal to negative 120.